Hello. In this video, we're going to start moving into chapter 2, where we'll start to discuss the ideas of sampling and overall data collection. Now, just a couple of quick things before we jump in. As I keep suggesting, you want to be reading the book in addition to going through these videos, and one of the major reasons, especially in the early going with class, it's a lot of information, a lot of examples. How do you know different things to think of? What are different possibilities? A lot of it comes from getting more practice. So in a lot of classes, practice definitely comes from the homework, but in this class, part of that practice is, again, going through the book, getting through the reading, looking through those examples. I think reading over the sections is a nice, again, reinforcement of everything we discuss here, but a lot more so to get more of those examples, to have a real full, diverse array of examples in all different types of areas. So the other tiny little thing though, especially as we get into chapter 2, you'll notice as we go along, we kind of focus a little bit more on sections 2.1 and 2.2. When we get to the experimental stuff, we're going to go through that a lot more quickly. So I'm trying to bring this up. This is not just vocabulary. As we said in the first video, there's never a point where it's can you define this? It's all about the understanding and a lot of can you give an example? Can you explain? So you don't need a verbatim definition for that. You just need the general understanding. So you'll get some vocabulary that we need to be familiar with. But if you read through all of chapter 2, which again you should, but realize for the experimental part, they get into extra terms like confounding variables. And there are other things. You should know what a placebo is. So other good stuff to read, but stuff that's not going to be so directly what you're being tested on, so to speak. And the last part, there's no posted homework problems for this chapter. There's really 3 big questions that you should be able to answer. We'll go over them one at a time as they come up in the section, and then I'll remind you at the end. But even right from the get-go, what are the 3 things you should be able to understand from this unit? I mean, in general, I always say the beginning of a chapter, they always have some nice goals. They always have that right up at the very beginning. Where is it? Before the chapter even starts, just a quick little, what are the learning objectives? What are the goals? So it's always good to read through that. But this, I'm even giving you a little more information, making it clear, what are the types of questions? So those questions are, why do we need to sample, right? Why not just use the population? Some explanation of why sampling, why we use samples instead of always just using the entire population, and being able to give an example of some sort of situation that mirrors that to kind of, again, demonstrate. Oh, we'll talk a lot more about examples and writing. We have a whole separate video where we'll start getting into that. And we could always ask questions. But one quick thing I want to be clear, when I say give an example, it doesn't have to be you go find an actual real example. I saw this in the newspaper. I saw this online. You truly can just make it up. Okay, just make your own scenario of what is something that would make this happen. So we'll see some of that. But that's the first thing. Being able to explain why, what is the need, the necessity of sampling over using the entire population, and being able to connect that with an example. The second part is being able to explain the difference between an observation and an experiment. And again, most of these explanations, the way to make it clear is to use an example to highlight it. So that'll be something else we discuss. And the third part will be discussing sampling bias. And again, being able to give an example. That's where we're going in this unit overall. So how do we start? Well, again, all of this is trying to make sure we're focused on statistics in general. And all of this, everything about statistics is all about the idea of making good decisions. Using information, being able to analyze it in some way to make a good decision. But here's one of the first problems we have to recognize. There is a lot of information available. So how do we make good information? How do we make good decisions? Well, we have to start off with good information in the first place. So the book actually starts off with a nice little discussion about like dieting tips. There are lots. If you read, again, look online, magazines, whatever, dieting. People want to lose weight. People want to, get in better condition, whatever that is. But there's a lot of information about dieting. How do you know what is, what good decision you should make? Well, you'd like to know in the first place that they're basing that information off of good data in the first place. So how do they collect it? And all these things. What types of information? Well, different people, different situations, different information might be important. If we're talking about dieting and you're a high-level athlete, you're going to want to look at different information on how to improve versus somebody else who maybe is 20 pounds overweight and they're trying to lose some weight. So it's not just dieting and here's all the information we need. What is it that you want to know about dieting? What is it about, your goal? What decision are you trying to make? That already tries to dictate what information would be more helpful. So what data it is that we would actually have to collect. Now, I also just want to take a quick moment. That's a very statistical based situation. But like I said, I always like to connect this back to the real world. It's not just statistics. We've always pointed out that people can try and deceive through statistics, but it's not just that. There are other places people do that as well, just based on some information that just kind of sounds good. Just a very, very quick example. This is, we hear a lot about trickle-down economics. It's a common topic that keeps coming up. If you're unfamiliar, just very quickly, the idea is that if you loosen up regulations, lower taxes on big companies, that those companies would then have more money, and by having that more money, they would then expand their business, and by expanding, that would provide more jobs and more opportunities for regular people. Again, it sounds good. This is not data yet, right? I'm not trying to say what data they have. This is just purely an idea, and just trying to point out that, again, when people say things, it's very easy to have something else to follow and say, okay, sure, that makes sense. But if you really think, and especially if you know a little bit more about economics, you could realize that that's not a real good argument in the first place. That just by giving companies more money, that doesn't give them motivation to expand. Companies try and expand when there is a bigger marketplace. So when they're selling more stuff, that's going to make them, give them more motivation to make more stuff so that they could sell even more. So it's more of like a supply and demand issue. So just in general, there's always different situations and information being thrown out there, but how we make good decisions, we have to make sure the information we're getting is good and it's also on point. So that's kind of a big general introduction. But if you just jump right in and start reading, the book really starts getting off talking about the idea of observation versus experiment. But I still think we need to take one more quick step backwards. That very first question I started off with, why do we sample? In our chapter 1 video, we talked about the difference between a sample and a population. And again, why we need to be so exact in our wording. So again, we still have a whole nother writing video to come up to talk about how to do this, especially if, your grammar is not the best. That's fine. You could still convey ideas. That's what the written word is, right? You need to be able to express yourself, to convey thought, to convey ideas. And even without the best grammar or habits, whatever, there's a lot of good ways you can still do that. But why do we sample? Population, well, we have to be clear who our population is. Is our population everybody? Is that all people? Is that only a specific gender, a specific age, people who live in a specific region, a specific state? All these things we have to clarify to be clear. Who is our population? And I keep saying who like it's people. We're not always just collecting people information, but just the idea of everything, everyone. So why would we need to sample? Well, a lot of it is practicality. For so many of these situations, getting the entire population, well, there's just too much information. Okay, so let's stick with people. I know I just said it's not always people, but let's stick with people for a few more minutes. If we want to know something about all the people in the United States, well, there's over 300 million people in the United States. So if you want to collect all that data, it doesn't matter what that data is. How much money people make, how many kids do you have, do you own your home, do you rent, do you own a car, do you have pets? Whatever the question is, if you're trying to collect all that information, that is going to be a lot of work. Just the time to go through and find everybody, the energy to go and do that, the money you have to spend to pay people to go and collect that data, to then compile it after the fact. So it's just, the book simplifies and just talks about limited resources. But those resources, time, money, it's just commitment. There's a lot of things that go into it. And for a lot of situations, it's simply not feasible to get everyone. So practically speaking, well, if I want to know about all the people in the United States, well, if I can get maybe like 1,000 people from each state, hopefully that will give me a good idea. The idea to try and generalize information from a sample to the entire population. Now again, there's more to it than that. There's a lot of other particulars. We still have to talk about bias, talk about what is a representative sample. But that's kind of the rationale, the reasoning for sampling. And we're not just trying to do it because it's, we're trying to be lazy or we're trying to cut corners. Sometimes you only have so much budget. So if I only have this much money, well, that allows me to survey, 1,000 people in my local township. Well, then that's what I have. So I have to do the best with it. So a lot of it can be limited resources. But for another example, let's say I'm a light bulb company and I want to just study what is the lifespan of my light bulbs. Well, if I want to really study that and look at my population, well, I have to take literally every single one of the light bulbs I've made, plug them in, see how long they last, see until they break. Well, that's going to take a long time. But the second big thing, now I have no product. So, just again, another practicality standpoint. I'm not going to test all of my light bulbs. Even if I want to know that information, I still want to continue to sell them in the meantime. So I make choices. And again, it's not just light bulbs, it's any kind of product, quality control. We're always trying to test these types of things. But again, you can't test everything. Some things you can test. If I'm just checking, like I make a helmet and I have to make sure this helmet will, provide support if you get hit by a hammer or something like that. Well, we could literally go and hit every helmet with a hammer. Is that still practical? That's a whole nother question. But for some of these other situations, how long until these batteries die? How long until this light bulb? How long until my TV burns out? All these things, you're not going to do that. Wait until all of your products break to get at the most accurate number for the entire population. Again, you're going to do sample. You're going to say, take 1 out of these 20 televisions, 10 out of these 1,000 light bulbs, something like that. Another rationale and reason for sampling. I hope you realize as we gave that discussion, I've answered the question for you. So again, it's not that there's, your homework here is to make sure you can answer these questions, but there's a whole bunch of information about why do we sample overusing the population every time. There's plenty of good reasons there. And to give an example, well, I gave you 2, and there's so many other easy examples you could follow up with. Another quick thing to mention, the idea of the entire population. We do have the census, right? Every 10 years, we do collect the census data, trying to get to every household, every person in the country. And while we're doing that, let's collect tons of information. Because again, it's a whole big process. It costs a lot of money. If you follow anything in the news, the census is incredibly costly. It's incredibly time consuming. So just to do it once, but then if we're going to try and do it every year, just how much time and effort. So again, for several reasons, we do it every 10 years to, again, try and limit how, the exposure, how much resources we have to commit. But we also don't want to wait too long because, we use this information to update, information about funding. How large is a school district? Do we need to reallocate resources? Or with regards to population, when we redesign congressional districts, how many members of the House do you get? So there's a lot of other reasons we collect that kind of information. But just to realize, that is a good example of trying to get the entire population, but how difficult it really is. So all of that, a lot of introduction, a lot to get us to where the book really starts with section 2.1. So we want to start off with observation versus experimentation. So again, our book gives us some definitions, but the idea of observation is this idea of, how do they phrase it in the book?
it's important to obtain samples that are representative, but I'm sorry, we want to observe characteristics in members of an existing population and use that resulting information to draw conclusions. And again, they're observational in nature. Things like you're checking maybe a water contamination, or you're trying to check speeding habits on the highway, or you're trying to check maybe a population of a particular type of bird in a local forest or something like that. So that's our observation, is the idea of kind of actually going out, collecting data by seeing what's there. And, part of this is, you can kind of collect this data. Some of this goes a little more easily when we're not dealing with people. So there's no issues about like getting people's permission and things like that. And the idea of being representational. Mentioned that word before, but now we're really just starting to get into that if you're doing this type of observational study, the idea is that in some way, the sample you get mirrors that of the entire population. So the easier way to do this is to go back and think about people. That if I'm trying to collect information, and let's pick an example. So let's say I want to know what are the earnings for college-educated women. So it's a good topic. I want to collect that information, but let's say I go and collect that information on a college campus. I'm getting information, and I'm not in a terrible place if I want to get information about college-educated women. And notice, I still need to be more clear. Does that just mean that you've had some college? Does that mean that you've graduated? Again, all the little extra words to be exactly clear by what we mean. So let's say I just mean someone who has had some college, not necessarily a graduate, some college. And I want to know about their earnings. So I go and ask women who are on some college campus. Is that representational? Now, in a lot of ways, I intentionally picked that first example because in a lot of ways it sounds good. We're talking about college education and we're going to a college campus. But is that the only place? And now we got to think, what are we trying to do with this information? If we're really trying to figure out like long-term patterns in salary, if we're just trying to figure out average earnings, well, if you're talking to people on the college campus, there's other factors, there's other variables that are involved, and maybe probably we're going to get women who are earlier in the workforce. So by that alone, it may feel like the numbers we're getting, that the salaries that we're seeing are lower than we expected, but we're not getting on a college campus the women who have been at work for 20, 30, 40 years, who are at the top of the salary chain, who have moved up and advanced a lot. So that's what we mean about being representational, that when you're trying to do your sampling, it should try and represent in all different areas who the entire population is. So now, a second follow-up. Stick with salaries of college-educated people. If I only ask women and I don't get any men in my sample. Now, maybe the numbers may not be that different, but maybe they are. There is a lot of information that shows that men are paid on average more than women for the same position. So that could throw us off. So sometimes it's very easy to say, well, you're missing a big group. Sometimes it's not so easy. As you read further, and we'll discuss a little bit more, the idea of knowing you have a representational sample is more about collecting the data in the right place. It's not so easy to say, okay, I'm missing this person, I'm missing this group. So again, it's not the easiest thing to say, I need to make my sample representational. That's not the easiest thing to do, but it's certainly something we want to try and have. And anytime we're questioning what is going on with our data, especially if, things are not going, if we have other data, and now this new group of data isn't going in the same direction, those are always good extra questions to ask. Is my data representational? What am I missing? Who's there? Who's extra? That's a big part. So observational, again, this idea of just going out, seeing the information, and then kind of collecting it, writing it down. So that is very, very different than an experiment. An experiment is all based on this idea of cause and effect. An experiment is all about, well, what happens when? What is the effect when I change something? So a simple example, I want to see how students did on an exam. So I could go and collect my data, and that could be observational. Just go get their test scores, and I could start to, make some basic statements about, how well did that test go? Maybe if I'm looking at it for myself, should I tweak my instructional habit? Maybe I could have done things differently. Maybe I was trying something new. But basically, just the idea of getting that data would be observational. But when I have a specific, okay, here was the data, now I definitely want to try a new technique, or I want to try a new method of examination. That is now getting more into that cause and effect. Back to just basic tests. If I want to connect it, okay, you studied for 1 hour and got this grade. What happens if you study for 3 hours? What happens to your grade? Now you're introducing extra, again, factors, which we could formally call variables. You're trying to see, if I tweak a separate variable, does that have an outcome on my data that I'm collecting? That is where we fully get into the idea of an experiment. So notice, I didn't give you a complete definition. We're just trying to get the general framework. But now a box on page 30 gives a nice little summary of what we just said here. So, an observational study. A study in which characteristics of a sample selected from one or more existing populations are observed. The goal of an observational study is usually to draw conclusions about the corresponding population or about the differences between two or more populations. In a well-designed observational study, the sample is selected in a way that is designed to produce a sample that is representative of the population. So all of that connects everything about observational studies. But then when you get into an experiment, a study that investigates how a response variable behaves when one or more explanatory variables, again, those are some of the other terms if you keep reading, but we don't need to know all that, just basically how my test scores are affected if I change my study time, or if I change the time of day that I study, or if I change the manner in which I study. I'm looking at one variable while tweaking and changing some other variable, some other factor. So that's the main idea of an experiment. So, how one response variable behaves when another variable, also called factors, are manipulated. The usual goal of an experiment is to determine the effect of an explanatory variable factor on the response variable. A well-designed experiment, the composition of the groups will be exposed to different experimental conditions and determined by random assignment. So again, if you keep reading, that's where a full experiment, it's not everybody's in the experiment. That's where you have to have the control group versus the experimental group. There is a whole, especially when it comes to medicine, the idea, and it's not just medicine, but the idea of the placebo effect. Sometimes people are in an experiment, they're not even getting the real medicine, but psychologically, by being in the experiment, that results happen. So we have to separate all of those things. But that's the big idea. Observational study, you just basically can go and get the data, but we're trying to make sure our sample is representative to draw conclusions based from that data about the population. But in an experiment, how we're separating, we have specific variable that we want to test, specific variables, factors that we're trying to see how they influence that original, and we have all of our different groups assigned. So that's the big picture. Now they explain a little bit more about the different, variables that I mentioned. But the next big thing I want to point out is drawing conclusions. So the box at the bottom of page 31 does this. There's just a couple of things. Again, this is where I want you to realize these are not the essay questions like we've said. Can you explain the difference between observation and experiment? Can you give an example of each? We've done that. And again, the book gives you more. So you could definitely take our examples and make different ones based off of that. Other observations that would work. Other things that would need a full experiment to be able to measure some sort of cause and effect. So I'm not so worried about all the yeses and nos, but again, to highlight the main differences. In an observational study, it is reasonable to generalize conclusions about the population. it is not reasonable to try and draw any cause and effect relationships. There is no cause and effect. We're not looking at those extra factors. You have to, again, they make a note, you have to make sure that you still have good samples, still have more to talk about there, and even with good samples, still can't draw any cause and effect. But with experiments, can you generalize results? Not exactly, but you can draw your cause and effect. But you have to make sure if you do good random selection, then you can start to generalize. So a lot of little things there. That's still only 2.1. Now we get into the next big piece, the actually sampling and bias. So how do you collect? Well, one of the most common ways, especially for people just getting started, and by the way, everybody, I have to just take one tiny little break. We're still focusing on statistics in general. And I'm still talking about, again, gathering information, collecting data in general. If you were ever actually doing this for an observation or for an experiment, you're in a social science class, maybe a psychology class, something like that, and you're trying to, again, run some experiment, collect some data, observation, either one, or a hard science class, you're running an experiment, taking measurements, some sort of an engineering, trying to make some determinations. All these different situations, when you collect data, there are some rules as far as like precision, as far as measurement, especially when you talk about measurement. You shouldn't report numbers that are more accurate than your measuring device. So for instance, if you're just taking measurements, I want to see how far people can jump, but my measuring tape only goes to the nearest whole inch. Well, I shouldn't be guessing and start putting in fractional or decimal inches in my measurements. All I can do, if my measuring tape only goes to the nearest inch, then my measurements can only go to the nearest inch. And then when I start talking about the average measurement, the standard deviation, it has to be to that same spot. I don't want to start talking about, well, the average is 23.6 inches when none of the individual measurements had that fraction or decimal attached to it. This actually came up in a project I gave to a stats class a long time ago. I was trying to get them to measure body temperature. And we had a thermometer, and the thermometer went to the nearest tenth. 98.6 is standard body temperature. And I actually gave them extra data because I was intentionally trying to give them data where something was clearly wrong. Either our thermometer was broken and was giving us faulty readings, or people in our class were clearly sick. I mean, I had some of the people in the data I gave to the class, we took some data in the class, but then I gave them extra data. And I think I gave them something like 6 people in the class had over 100-degree temperature, and a couple of them had like 105-degree temperature. They'd be lucky to be alive with that kind of temperature. So I was intentionally doing that, but my point was, at the end of that, several students at the end, the numbers we should have got, well, we expect 98.6 for average temperature. Through the measurements, we ended up getting something like 99.3. So what I was hoping, the measure would be more of a question of how significant that difference is. Can we conclude that something is wrong, or is this just not enough information? We got a whole long bunch at the end to see that type of problem, and we'll get to that towards the end of this class, towards the end of statistics. But when everybody just, well, not everybody, but when students just rounded off, 98.6 became 99 degrees. 99.3 became 99 degrees. When you round things off too far, I mean, you might as well just throw your data in the garbage. But a lot of that, those are the types of things you learn in your major specific classes. So I want to point out, there is important aspects outside of what we're talking about when it comes to data collecting, to recording your measurements appropriately, to then what you do with the data after the fact. But again, just want to make that clear. For us, we're literally just talking about the actual collection method, not all data is numerical, as we know, but if it is numerical, not just the numbers itself. Okay, so sampling. A lot of people, when they start to realize, okay, I have to sample, how do I sample? They kind of do it in a bit of a haphazard fashion. And most of the time, if you do that, you're not going to end up with the representative sample that we want. So how do you collect? Well, again, first, we have to realize one more time, here's where they formally define a census, and they give us a little bit more about representation. What is a representative sample? And an important note, there is no way to tell by just looking at a sample whether it is representative of the population from which it was selected. Our only assurance comes from the method used to select the sample. So, two things. Basically, that if we're looking at data and we're just trying to make our conclusions, we have to trust that the person that gave us the data did it rightfully in the first place. And if we don't know that, if this is something out in the real world, well, that is always a good question that we should start with. If we're not being told, how do we get this data so that we have that good sense of, okay, we have a good possibility that it is representative. And before we could still get into all the different data collections, we have to talk about bias. Now, one more time, all the different formal terms. There is selection bias. There is measurement or response bias. There is non-response bias. Once again, I'm not worried if you could formally define each of those individually. I'm more concerned with, here's that third question, can you discuss bias? Can you give an example of a situation, again, make one up, where there is bias, some form of bias, and explain how that bias would affect the data or affect the conclusion that would be made. That's where we're trying to go with this. So formally, we have, again, the idea of, well, again, a non-representative sample in some way would have some bias. So selection bias. Maybe we're missing groups. You know, that in our selection, we are clearly just missing people. I want to talk about, you know, Queensborough Community College students, but then I look and realize that all of my students are, you know, age 18, 19. And I was like, well, wait a second, you know, we do have a decent number of what are called the non-traditional students who have, you know, come back to college or are, you know, either coming back after working or just, you know, looking at a new major, something like that. But if all of the students, when I'm trying to look at college students at Queensborough, and if all my students are in that age 18, 19, well, again, I'm missing a group. Maybe it's not that I need lots of students, but I should have students who are, you know, in their 20s, in their 30s, because that would be representative of the population of Queensborough students as a whole. In selection bias, so they talk a little bit more about that. Missing groups, and again, we try, and there's a, you know, when we get to the sampling techniques, the methods we'll try will, again, hopefully allow us to avoid that. If we're doing some good random sampling, for instance, well, we'd be very unlucky if we missed all of those students that I mentioned. But a second thing we have to point out, if you only look for volunteers, you will always have selection bias, okay? Now again, it's very common, right? You're trying to collect data. There's a lot of situations, you know, we'll talk about surveys later on as well. But if you're only getting information from volunteers, like, it's almost like they want to share. So it's almost like they're more opinionated than the entire population as a whole. So you're getting a higher representation from people who are strongly opinionated when the population as a whole is not that opinionated. So again, it's something that makes a lot of sense. We want to collect data. We don't want to intrude on other people. So sure, we'll just get volunteers. But that idea of voluntary information, you know, Rate My Professor is a good example of this. If you don't know, ratemyprofessor.com or Rate My Professors, I forget if it's plural or not. But it's a very common website that's been around for a while, and it has some ebbs and flows with how much students seem to be using it. But you can go there and look up a professor and, you know, either write a review if you've had them or read what other students have said about that person. But think about that for a minute. Who is going to go to that website and write responses? Most of the time, it's not 100%. In statistics we see, there's things we could say, but you know, there's always that most of the time situation. Most of the time, it's not just Rate My Professor, but things of that nature. You get people that are strongly opinionated. People who really like that professor are going to go out of their way to make sure they give good review. Or the other side, people who really, really didn't like that professor, really want to use that as an opportunity to make it clear that they were unhappy. And, some of them it's a little bit of they want to bash, but others it is to share information. But those, if you go to Rate My Professor, so often those are the two extremes that you see. Really, really like, really, really hate, very, very few in the middle. But the reality is most of the people do find themselves in the middle. So like I said, a lot of those situations, it feels like you're collecting good data. And again, for something like that, if you're just trying to make a decision about like, okay, I'm trying to pick this class, I've got 3 or 2 different professors to pick from, all of these sections fit in my schedule, so who should I pick? It's good to have information. And, you can try and think in your head, well, the more people who like this person, that's got to be a benefit, whereas this person definitely had a lot of people who dislike them. So you could still try and use that information, but it can't be like, well, this is definitely the way it is. And this person had good reviews on Rate My Professor, so I'm guaranteed to like this professor. That's just not the way it works. So selection bias. The second one they talk about is measurement or response bias. Now they do talk about, again, sometimes that could be you're actually collecting information and you've got a ruler or a thermometer or a scale, something like that, and maybe just truly that measuring tool is broken in some way. So that can come up. And that is certainly an issue. And, that's why, again, all these different situations, if you do get into those fields, if you are a scientist and you're experimenting and collecting that type of data, well, that's why we don't just do an experiment one time, and that's why we don't just always use the same tool. And that's why other people repeat an experiment, because we need to see consistent results. And to know, okay, it's not just a fluke. It's not just this sample. It's not just this measuring tool. So that's a part of measurement bias. But especially when you start talking about response bias, a lot of this comes from asking bad or misleading questions. This is kind of a place, well, what's a bad question? The word bad is a little relative here. It's more the idea of a misleading question. And misleading questions we see this all the time. Polls, different news networks, they want to make their point so to get data that will favor their view. And this is what I keep suggesting. The idea that statistics doesn't lie, but liars use statistics. This is exactly what I'm talking about. If you ask a question the right way, a lot of us have a lot of filters in our brain. So when you already trigger a certain response, and you could do that with certain words. For instance, again, they've got several examples in the book. And again, it's right off the bat, and they give some later as well. Misleading questions. Are you in favor of Joe Biden's horrible idea to put another $1.9 trillion back into the economy? It's a fair question to say, are you in favor of Joe Biden's stimulus package? But to throw in that word, this horrible idea, I'm already tilting your view. I'm using a word with a very negative connotation. So for a lot of us, not all of us, for plenty of us, we could see through that, but it's a very natural response that you already have that negative picture. And I could just as easily flip it. Are you in favor of Joe Biden's wonderful idea to spend another $1.9 trillion? It's like, no. Questions, when you're trying to get real type of answers, they should be neutral. They shouldn't have any of those misleading terms. So again, I gave you example on a national scale. You could definitely break that down on a more local scale. The local high school is considering building a new gymnasium, or is considering upgrading the computers in the technology lab. Different things like that. And I'm leaving that as a very neutral question. Are you in favor of the fundraiser? Would you support them? That's fine. But again, any of those, a horrible idea to try and raise more money from an already hard-hit community. All those types of words really, really do get into us. Now, it doesn't have to be politics. Again, there could be plenty of other things as well. Like I said, maybe you're just collecting information about a teacher. Same thing. Maybe you're trying to get an opinion about a consumer product. You're looking into this television or this type of computer, but same thing. I want to know, how do people like their iPads? But maybe I don't like mine. So I want to see other people don't like theirs. So I talk about the troublesome, terrible iPad. Or again, the flip side, I love my iPad. I just got it and I can't get over how great it is, or my new iPhone. So I ask, how much do people love their new iPhone? So all these different things. By sticking those extra words, you are manipulating the person, and therefore the data you get is going to be swayed in some way. So that's what we talk about with measure or response bias. The last one is this idea of non-response bias, and surveys are a great example. So non-response bias occurs when responses are not obtained from all individuals selected. So again, this kind of goes back to the idea of voluntary. If I want to collect, a class survey information, well, I want all of you to fill out that survey. And now I can trust the results. But if I say, well, you don't have to, and this is why, we're not in person, but in regular in-person classes, you do see the people, like when you do class evaluation surveys at the end. Everybody who's there fills one out. You can't just say, no, thank you. It's like, no, we need to collect all that information. So again, it's not just the people who really like the person filling out the survey or the people who really didn't like the person. We need to get it all. But now again, of course, it's common. You go shopping, or you call a phone line, you need to get some information about your credit card or something like that. And then they ask you, will you stay on the line to fill out this survey? Or when you're at the store, they hand you a little evaluation card. You're at, hey, you go get fast food. Almost always on the receipts, hey, fill out this survey. Tell us how we did. They're trying to get as much information as they can. But those surveys always have non-response bias because, as we keep saying, you're always going to get the highly opinionated people, and you're not going to get those middle-of-the-road people. So they give you a nice little summary at the bottom of page, 35, on more types of bias. But again, big picture. Can you give me some example of a situation and talk about how bias, why we'd have to be careful? So again, this could go into any direction you want. You can make up any scenario at all about consumer products, about people's responses, about grading, about testing. Any different field you want to go into, and then you could find a way to talk about one of these aspects of bias. So there is your last kind of big part for this, as far as what you should be able to discuss. And to make sure, if you're clear, now you've got the 3 big questions. And notice, they all involve some discussion. It's not just a one word, it's not just give a definition. It all involves some comparison. Give an example of this versus that. Give an example that demonstrates what you mean by this. That's where we're going. That's what you need to understand from this chapter. Now, we're still not done, but we got through most of the big stuff. That gets us through page 35. That's only about 6 pages, but there's still a lot more to read and a lot more that you should go over. Again, page 36, a few more good examples just to keep seeing, understanding the differences, and then it starts getting into the different types of sampling. And the ideal is the idea of some random sampling. If we can really do random sampling, then that's going to be our best key, so that we're not trying to find a representative sample, but that we can naturally end up with a representative sample. But when you are going out and collecting data and specifically asking individuals, that's where we can definitely get into trouble. So, can you still do that? You can, but that's where, again, we have to be very careful, and in discussion have to be very clear that was the situation, so we don't want to over-exaggerate the results. It's what we've seen, maybe it supports, maybe it doesn't support what we thought, but always that more information would be necessary. And maybe part of that more information would be better sampling would help to get better data to help make these conclusions more conclusive. So, random sampling is the idea. And another quick thing, sample size. How many people, how many objects? Well, the short answer is the more the better. But, what is more? Well, if we're looking at, a couple of classes that consist of 100 students, well, 30 is probably going to be a decent total. But if we're looking at millions of people, 30 is not that many. So maybe now we want to get into the hundreds, maybe the thousands. But it's always kind of a situation. More is always better. More is always going to make that data more, again, assuming we collected the data the right way without misleading questions, more data will always be beneficial in some way. And just in general, N. We always use the letter N to talk about sample size. I surveyed 20 students out of this class, N equals 20. I surveyed 400 New York City residents, N equals 400. So just to already establish that, we always use the letter N when discussing how many objects, how many people, how many pieces of information we collected. So, random sampling. Well, again, they talk about sample size N. They do mention that specifically at this point in the book. But random sampling. Well, they talk about the idea of trying to be random. So if in an ideal world, if every object was available, well, if I sampled every 5th object or every 10th, that would give me random. So if we're talking about people, if I could line everybody up and then grab every 5th person, that would probably work. It's not always quite possible to do that, but that's kind of our ideal situation. But other techniques, they talk about stratified sampling. Maybe, we're trying to look at doctors and their pay, but, well, actually, they use doctors in the book, so let me go into a different category. Maybe I want to look at business executives. But then I realize, different categories of business executives. Am I looking at management? Am I looking at accountants? Am I looking at efficiency experts? I'm probably going to get different information if I look at each one of those separately. So I can collect all of their information, but keeping them separate into separate strata in separate classes, that's a good thing. And that may allow us to use the data in more than one way. So instead of just looking at all of these are business people, well, I can do it that way, but I also have my data separate so I can just look at accounts. I can just look at efficiency experts, and so on. Cluster sampling. Again, if people are randomly grouped, but if I just grab a cluster of 30, that might possibly give me a decent system, a decent representative sample. Then the idea of systematic. Well, if I have 200 people, if I grab every 5th person, probably that would give me a decent representative sample. But then they point out this idea of convenience sampling. This is kind of back to the haphazard, but the idea of doing what's easy. You want to collect information, so you ask the easiest people. You ask the people sitting next to you in class. You ask the people that you work with. And again, you can get good information from that, and that might be helpful, but it's just so unlikely that that's going to be representative unless your population is already those people that are in close proximity to you. But if you're just looking at, okay, I want to look at people in my neighborhood, but I only ask my next door neighbors and my friends, that's not really representative of all of your neighborhood. There's almost certainly some neighbors you don't like or certain neighbors you don't know. And we'd want to try and get those people included as well. So the idea of convenience, we have to do it sometimes, but that's not an ideal way. So that really takes us through the heart. Section 2.3, that gets more into experimentation. And again, they try and make it clear in the beginning, you are trying, if you are doing an experiment, that there has to be 2 factors at least. One factor you really care about, like test grades, and another factor that you want to look at how it influences that initial one. So how long you study, to how that connects to a test grade. What was your SAT score to how well you did in your first year of college? That you're trying to see how one variable influences another. So that should always be clear in designing any experiment. Again, they do a little bit more with some variables, some random assignment. they eventually start a couple of examples if you want to read through. I hope I'm being very clear here as I'm kind of breezing through this. We've already discussed the big pieces. This is just a little quick for your information. Some of you, again, you may actually need to run some experiments down the road. So just to get your feet wet here, just to get a little bit of that initial exposure. 2.4, a tiny little bit more about the idea of like blind experiments, the idea of a placebo, of a control group. If you've never heard of those things before, most of us have at some point, but just to get some formal definitions. And the final bit, a word to the wise. Page 66, it's only the last 2 pages, section 2.5, communicating the results. So they talk about the ideas of undercoverage versus overcoverage. If your samples are not representative, you're undercovering a certain particular sample of a population or overcovering. Just talking about how the information was collected. If you're communicating results, that needs to be clear and transparent. Again, when we talk about misleading statistics, some people, they try and hide those things a little bit, but good statistical work, all that information should be made very clear. So anybody who's reading this should be, very aware. Potential sources of bias should always be discussed. And again, that's where all people, we think statistics is about, I want this result, the result happened, I did a good job. Or, I want this result, the result didn't happen, I must have screwed up. That's not it. It's not about you get what you want or you don't get what you want. It's about being able to explain that things did go well, but this is what else we need to think about and still need to consider and still need to see duplicated. Or things didn't go well, but these are other things that might have influence, might need to be considered, can be done again, to look into deeper. There's always so much more than just here's the data, here are the results. They go a little deeper with experiments about what you can say, but at the very end, cautions, limitations. One more time, there is no cause and effect relationship from observations. Don't do this, don't believe it, you just can't. There's no, we talk about the science of statistics, there's no science there, okay? Observation again, generalizing results, especially with a good sample, but there's no cause and effect there. Next, generalizing results that uses volunteers, that's not sensible without a convincing argument that that group of volunteers is reasonably a representative sample. Generalizing conclusions based on data from a sample to a population, again, a sensible thing to do, but sometimes is not reasonable. So just a few other things to read over, but hopefully starting to get the hang of this, starting to realize what statistics is really all about, starting to realize some of your first test questions are definitely going to involve some writing. Your next video you should watch is our first introduction to writing, talking about the difference of writing in an essay, fully exploring an example, and then talking about papers. And to be honest, we're not that far away from our first paper as well. So last quick thing, chapter 3, everybody. For a lot of people, when we've now gone through 2 chapters and people are still, where's the math? But like I said in the beginning, there's a lot more to statistics than just crunching numbers. But chapter 3, we'll start to see a little bit more with numbers. We'll get into those charts and graphs. So even in the chapter 1 video, if you couldn't see my book and you don't have yours yet, you want to get back, you want to start looking at graphs and charts. But in chapter 3, that's what it's all about. So anything we may have said will be said again, and we'll see a lot more. We'll start to get to more of the traditional, what do I need to do? What are the problems? What are the things I need to answer? But even there, we'll still see a lot of the thinking. What does it mean? Personalizing a situation, looking at the data. What does that mean for me? Is that a class I'd want to be a part of? Is that a company I would want to work for? Is that a building I would want to live in? Things of that nature. So that's where we're going, everybody.